The comparison test is another method for determining convergence and divergence in series. It's very similar to what we did with infinite integrals in that we're saying that if our series is greater than or equal to a divergent series, our series will diverge, and that if our series is less than or equal to a convergent series, our series will converge. So remember, we want to show that it's greater than a divergent or less than a convergent. If we show that it's less than divergent, that doesn't really tell us anything, and so does saying that it is greater than a convergent series. So let's look at some sample problems where we can use this. So we have the series from n equals 1 to infinity of 1 over 3 to the n plus n. We want to compare this to a series that we know converges or diverges, and show that this converges or diverges. We'll notice that we're summing up values where n is always greater than 1 or equal to 1. N is always positive. So this 3 to the n plus n is always going to be greater than 3 to the n because n is always a positive number. So if 3 to the n plus n is always greater than 3 to the n, well, what does this tell us about 1 over 3 to the n plus n? That tells us that 1 over 3 to the n plus n is less than 1 over 3 to the n. Now, if we can show that 1 over 3 to the n converges, well, then this will be less than a converging integral. Or series, I'm sorry. Well, 1 over 3 to the n, this is just a geometric series where our r value is equal to a third. And remember, if our r value, the absolute value, is less than 1, which in this case it is, it'll converge. So since our series is less than a convergent series, our series converges. Now let's look at a bit of a trickier sample problem, and what I would like you guys to do is take a minute, pause the video, and just try it out, and then if you get it or not, just check your work and come back. So now let's go over this problem where we're looking at the series from n equals 1 to infinity of n over n squared minus cosine squared n. Well, notice again we're looking for at positive values of n, but if you notice this cosine squared n, well, what do we know about cosine squared? If you look at a function of cosine squared x, you can see that it's a periodic function, but it's always positive. It's always greater than 0. So what this tells us is that since this value is greater than 0, this value is greater than 0. I'm sorry, that looks really bad. Well then, n squared minus cosine squared of n is going to be less than n squared. But what does that tell us about this series? Well, we can do n divided by both sides and see that n squared minus cosine squared of n is going to be greater. We just flip the sign since we're dividing. It's going to be greater than n over n squared. So we're greater than, and we hope that this is something that diverges, and well, n over n squared, just divide by n, and we get 1 over n. And this is the harmonic, which is one of those series that you should know diverges. So our series is greater than a diverging series. And since our series is greater than a diverging divergent series, our series diverges. And that's it.